if you were given arc tangent square root of 3, well, is equal to something. Let's just call this something x. So we're trying to solve for x, right? Do you guys agree that this is the same thing as tangent x is equal to square root of 3? See if this makes sense. Yeah, it should be in your notes. We're following your notes right now. Okay. Yeah, well, we're about to fill that out, but not yet. Okay, so guys, follow your notes. If you're looking for the inverse of tangent, and guys, in pre-calculus, do you remember your teacher telling you that arc tangent is the same thing as inverse tangent? Probably because she or he didn't. Okay, well, in calculus, you're going to see these interchangeably. So make sure you understand that notation-wise, tangent inverse or inverse of tangent is the exact same thing as arc tangent. They're just synonyms. I don't know why there are two ways to write this, but anyway, they're synonyms. And so if you want to find the inverse tangent, it's really just saying, you know, whenever you have tangent x equals 3, do you remember that this is the angle? Do you remember my telling you that the angle always sits next to the tangent or next to the sine or next to the cosine? This right here is the coordinate, okay? And this is the angle. So right here, if you have inverse tangent, what they're saying is, this is your coordinate. This is your answer. Now tell me what the angle is. They're asking you for the angle. Do you guys see? They're switching it. Because an inverse is just switching the x and the y. So when they switch this, that's the inverse tangent, okay? So really what you're saying is, guys, on your unit circle, okay, at what angle is your tangent value square root of 3? So let's go back to your unit circle. We're going to do a little bit of review because it sounds like you guys need a little bit of help with your unit circle, okay? And your unit circle, guys, is actually not that hard. You really just need to take this piece of paper, go into a closet, fill it out, turn on the light, fill it out, and you'll feel much better about the unit circle after like 5 minutes, okay? So let's just go ahead and do this unit circle because you guys know this. Let's just do the 90 degrees first, the quadrangles. If this is 0, what's this up here? Do you remember? Pi over 2. What's this down here? 3 pi over 2. All right, let's just do the 30, 45, and 60. What's this one right here? Pi over 6, then pi over 4, then pi over 3. Now it gets a little bit harder, but actually I don't know if you noticed, but you just end up counting here. 2 pi over 3, then 3 pi over 4, then 5 pi over 6. Now see if this makes sense, guys. Look, 2, 3, there's a little burp at 3, but 2, 3, 4, 5, 6. You see they're really just counting, but there's a little bit of a burp at 3, okay? But other than that, it's just counting, okay? Well, this right here is 6 pi over 6. Okay, so really you just add a pi over 6. So if this is 6 pi over 6 and you add a pi over 6, where are you at? 7 pi over 6. So that's how I remember it. This is 5 pi over 6, you add 1 6, so that's 6 pi over 6, and you add another 6, you get 7 pi over 6, okay? And if you think about it, I think, no, it's not always adding. You're always adding by 6's 1 over 6, like when you skip this 45 one. Okay, this one is just counting backwards. So 7, 6, guess what? 5 fourths, but then there's like a burp at 4, okay? That's probably not a mathematical word, but there's a burp at 4, so 4 gets repeated, okay? But it's 7, 6, 5, 4, 4, 3, 2. You guys see that? Okay, I guess you could say there's a burp at 3 too. There's a lot of burps in here, okay? So then the way I remember this side over here is if this is 4 pi over 3, I just add 1 to this, and I just think this is 5 pi over 3. That's how I do that. I say this is 4 pi over 3, so that's 5 pi over 3. Do you remember these two here? Not used as often. 7 pi over 4, and the last one, which we almost never use, yeah, 11 pi over 6. See, you guys know this. All right. Yeah. Oh, tell me again. 6, 4, 3, 3, 4, 6.
But if you go from the inside.
Oh, they repeat themselves, right? Yes, that's true. You're right. Oh, you did? That's nice. Like ET's phone number, kind of like. That's nice. Okay, that's that song. 657, whatever that number. 6. Oh, 867 5309. That's from ET. Yeah, it's from the movie ET. Well, it's in there. I don't know if it's I don't know if they actually use that number. Yeah, I don't know. We should dial it and see whose phone number it is. I don't know. Okay, so right here, the coordinates. This is 1, 0, right? This is 0, 1. What about this one? -1, 0. So what's this one down here? 0, -1. Okay, the first number is the what number? The cos x or the cosine, and the second number is the y or the sine. Okay, and then in these 45 degrees, it's always the same. You guys good with this? The 45s are always the same. I'll add the signs in, but really, these are all the same. You agree with that? And then let's just do the sign. So this is always plus plus. This one's always negative plus. This one's negative negative. This one's plus negative. So let me just add negative here. Make these both negatives. Put a negative here. Everybody good with that as far as signs? Okay. And then there's this special thing where if you, let me see if I can get a highlighter. Let me get a yellow. Okay. If you just go like in the vertical boxes. So I'll just do the vertical boxes here. Okay, the vertical boxes are kind of special because they have all the same numbers, and then the horizontal box has all the same numbers. So what do I mean by that? All the vertical boxes, you go over a little bit and up a lot. So it's all 1/2 square root of 3 over 2, like over a little bit and up a lot. So all these numbers are the same. Okay, so all these boxes are the same. Over a little, up a lot, or down a lot. Over a little, down a lot, right? And then the fat box, okay, the fat box here, that's probably not PC to say, but I don't know what else to call it, but it's this squat box, okay, right here, okay? That one is just the opposite, right? You go over a lot, up a little. So guess what the first number for that is? Yeah, so then you just put the root 3 first, and you put the root 3 first, and again, the root 3 first, and I can come back and put in all the signs, right? So that one's negative here. This one's negative, negative. This one's negative, negative. This one's positive, negative, positive, negative, positive, negative. And I'm probably forgetting these up here. Negative, positive. Everybody good with that? Okay. And then the tangent values, I asked you guys to memorize. Do you remember this? The easy tangent values are the ones with square root of 2's over 2's. What are all the tangent values square root of 2's over 2? They're all ones, okay? It's just that in the second quadrant and the fourth quadrant, you have negative ones, but everywhere else you have positive ones, okay? But the other tangent values aren't that hard to memorize either, because the ones where you have the yellow box, do you remember what I told you those are? They're all square root of 3's, so those are not hard to memorize. You just have to know that the second and the fourth quadrant, you're going to have negatives. Okay, so this is negative square root of 3, where it would be here, and this is positive square root of 3, okay, because it's negative divided by negative. Guys, what about the red box? What are the tangent values for that? Square root of 3 over 3, okay? And the easiest thing to do is just memorize it. Square root of 3 over 3, square root of 3 over 3, square root of 3 over 3. Trying to get in the right box here. Square root of 3 over 3, and then get your signs right. This is positive divided by negative, so this one's negative, and this one's negative divided by positive, so this one's negative. Where is square root of 3 over 3? Okay, but otherwise, they're all square root of 3 over 3, and the other ones are square root of 3's, okay? And then finally, these are zeros, right? And what are the top and bottoms? Undefined, because you're dividing by 0. It's y divided by x, and y divided by x. Do you see how easy the unit circle is? And you guys know it. Oh no, but you don't have to draw the whole thing. But what I'm saying is like that if you could get any one number that you needed, you know, by doing that, right? I mean, I wouldn't ask you for all of it one time, but you might say, hey, what's the tangent of pi over 3? Then you'd be like, okay, here's pi over 3, and then tangent would be, oh, they're all square root of 3's. You know what I'm saying? Just that logic involved. Okay, you have to draw the whole thing. No, you don't. Okay. Then I'll just give you a quiz on the whole thing then. Okay, I'm just kidding. Okay, right here, guys, tangent x equals square root of 3. Okay, so think about your unit circle. Where is your tangent value square root of 3? Where is it? Pi over 3, and where else though? There's actually one other place. Is it right here? 4 pi over 3 and pi over 3. Now, what I need you to do is go look at your notes, and I have like this little circle thing for you, okay? And you learned this in pre-cal, and we're gonna re-emphasize it here, okay? When you have arc sine, arc cosine, arc tangent, your answer can only be here. It's only allowed to be here on the circle, okay? Highlight that part on your circle. When you have arc cosine, arc secant, or arc cotangent, you're only allowed to have an answer on this top part, okay? And what do I mean by that? What I mean is when you choose your answers, okay? So let me pull over here and pull this a little bit to the right. When you choose your answers, you're only allowed to choose these answers. So watch. This answer can only be negative pi over 2 or negative pi over 3 or negative pi over 4 or negative pi over 6 or 0 or pi over 6 or pi over 4 or pi over 3 or pi over 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. You're only allowed 9 choices, and that's it. Okay? Do you see your choices here? Okay? Now, I want to clarify something. One of your choices is not 3 pi over 2. So even though you have a 3 pi over 2 right here, okay, that is not your choice. You have to go negative here, okay, for your choice. And you have to go, you can go positive here. You're used to that. But these have to be negatives, okay? I know this is 5 pi over 3, but you can't say that. You have to say negative pi over 3, okay? That's just the rule for arc sine, arc cosecant, arc tangent. The other ones are a little bit easier. These up here are just like your unit circle. So you're allowed to say 0 here, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Guys, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible answers. That's it. You guys good with that? When they're asking for these arc answers. Of course, there are more answers if you had decimals, okay, in between. But I'm talking about numbers from the unit circle. These are the only ones you could have, okay? All right. So guys, this answer, okay, is an arc tangent. I'm only allowed to choose. See, arc tangent, I'm only allowed to choose this right side. So which answer is it? Pi over 3. So the answer to this is x equals, or this arc tangent here is equal to pi over 3. Okay, let's do another problem. Cosine square root of 3 over 2. All right, this again is an arc cosine. I'm going to say that that's equal to x. The rewrite of this, okay, to make it something I understand is really the cosine of what angle is equal to square root of 3 over 2. That's really what they're asking me for, okay? So I go to my unit circle and I think about where in my unit circle is cosine square root of 3 over 2. That means my x value moves positive to square root of 3 over 2. There's only 2 places. What places are they? Pi over 6 and where else? This angle here, whatever that is, 11 pi over 6, right? Okay, but guys, think about, this is an arc cosine problem. I know it says cosine, but it's really an arc cosine problem. Look at your arc cosine. You can only choose between these answers. What is your answer going to be? Pi over 6, okay? So even though it looks like it could have been 11 pi over 6, you can't choose that one. Now I need to clarify for you guys before we go on. Why is there only one answer to this? It's actually arbitrary. I just want to, don't think about it too hard. It's actually arbitrary. Somebody super smart said, hey, with inverses, you can only have one answer. And since you can only have one answer, I decided that these 3 inverses can only have top answers. These 3 inverses can only have right answers. It's totally arbitrary. So you just memorize it, okay? Now, why does it have one answer? Now, I need to clarify something to you. If this had been your original problem, tangent x equals square root of 3, this would have had an infinite number of answers. Tangent x square root of 3 has an infinite number of answers. You could have been here, you could have been here, you could have been back here, you could have been back here. Like, it goes in a circle. It's an infinite number of answers. But once they put this arc tangent, this inverse, then you only have one answer. Okay, so let's go back. See this cosine x square root of 3 over 2? If this had been your original problem, you would have had an infinite number of answers. Your answer could have been here, your answer could have been here, then you kept on going in a circle. You could have had an infinite number of answers. But as soon as they put this inverse in, you only have one answer. Now, some of you guys are like, wait, that's weird. How can that be? You've done this before. When you were in grade school, do you remember square root of 16? Do you remember what that was? 4. Do you remember going around and saying, ask me any square root? I can tell you. Ask me anyone. Say, like in first grade, you're like, tell me, square root of 36, 6, square root of 49, 7. Like you'd ask people to ask you that. Do you remember that? Okay. Okay, maybe second grade? Okay. So, in kindergarten, yeah. So everyone in different places, right? Okay. But guys, remember when you went to 8th grade, okay, or 9th grade, whenever you started algebra 1, and they said x squared equals 16. Now what was x equal to? Plus or minus 4. Now you had two answers. Before you only had one answer, but now you had two answers. Why? Because up here, this was x equals the square root of 16, and the answer was 4. This right here, now you had two answers. It became a quadratic. And so this became two answers. So now you have to have two answers. If you ever had three, you'd actually have three answers. They might be imaginary answers, but whatever this power is tells you how many answers you have, okay? So this is the same thing. When you just say square root of 16, you have one answer. But when you have x squared equals 16, which is almost the same thing, you have two answers. And so it's the same thing that we're saying here. When you have tangent x equals square root of 3, you have an infinite number of answers. Even though this is the same as this, as soon as you have this inverse, you only have one answer. Okay, it's just a weird, funky thing, but that's how inverses work. Okay, so let's do this problem right here. Cotangent 1, inverse cotangent 1 equals what? Guys, what I do is I just say that equals x first. And then I rewrite the problem because I don't really understand inverses, but this certainly makes a lot more sense to me. This is saying at what angle, okay, is my cotangent value 1? But guys, cotangent is not on a unit circle. What is cotangent equal to? 1 over tangent. So doesn't that mean 1 tangent x is equal to 1, right? This is the exact same thing as this. But guys, if I have a fraction on the left and a fraction on the right and an equal sign in the middle, what can I do? Cross multiply. So what this is saying, that tangent x is equal to 1. Well, think about my unit circle. Where is tangent equal to 1 on my unit circle? Pi over 4. Anywhere else? Right here? What was that? 5 pi over 4. Okay. Now remember, this is a cotangent problem. So go look at your little yellow circles. Okay. Where is cotangent allowed to be? Cotangent. Right here. So I got to pick one of these. So which one is it going to be? Pi over 4. So this answer is pi over 4. You guys see how to do these problems? Okay. You guys do the last one then. Go for it. What'd you guys get? Pi over 3. That is your answer. Nice job. Okay, any questions about how to do this? Okay, let's go ahead and do the new derivatives that you guys are going to do today. So let's move on to, one other thing you need to know. Do these graphs look familiar, guys, from pre-cal? So Miss Puckett gave me this worksheet that had these graphs on it. And when she gave it to me, she warned me. She said, you're never going to find these anywhere. And she was right. Like it was the nicest graphs, and I can't find anything this nice. But these graphs are all your arc sine graphs or arctangents, your inverse graphs. But you actually only need to know this one. So let me just write down which one you need to know. And I don't know if this is on your formula sheet or not, but of all the inverse graphs, you only need to know one, and that is your arc sine graph. Your arctangent graph. If I ever ask you to graph arctangent, okay, you need to just know in your heart that it looks like that. That is your arctangent graph. Just be able to graph it, okay? Arctangent intersects right here at 0, 0. You need to know that, okay? You need to know that on the top here, it goes forever to the right, but it never goes higher than pi over 2. And on the bottom here, it goes forever to the left, but it never goes lower than negative pi over 2, okay? And that gives you 3 limits that you actually have to know. One is if you ever take the limit as x goes to infinity of arctangent of x, that is actually equal to what y value do you approach? Pi over 2. And if you ever take the limit as x goes to negative infinity of arctangent of x, okay, as x gets smaller and smaller and smaller, what y value do you approach this way? Negative pi over 2. And then another one that you have to know is a limit as x goes to 0 of arctangent of x. So if you come from the left or from the right, it really doesn't matter, of 0. What y value do I approach? 0. Okay, so those are 3 that you have to memorize. And I actually just kind of sketch this every time and look at the picture to answer these 3 things. Okay, and I think we'll be talking about that Thursday or Friday. Okay, so that's your arctan graph. You have to memorize that. And then these are your new formulas that you're going to memorize. When you first see these formulas, you're going to freak, okay? But I just want to tell you that even though they look terrible, the application is not bad, okay? The derivative of arc sine is u prime over the square root of 1 minus u squared. The derivative of arctangent is u prime over 1 plus u squared. And the derivative of arcsecant is u prime over absolute value of u square root of u squared minus 1. Okay, I want to show you something. There's a little bit of a pattern. You're going to have to memorize these. But I want to show you there's a little bit of a pattern. First of all, do you see that this is 1 minus u squared, and this is 1 plus u squared, and this is u squared minus 1. Do you guys see that? So if you have arc sine or arcsecant, you always have a square root. You always have a square root, okay? If you have an arc sine or arctangent, the 1 goes first, okay? So do you see this I right here? Do you see the I? See, that says the I goes first. Do you see that? See that I? See that I? The I goes first in arc sine. You just have to memorize that there's a square root down here. Arctangent doesn't have a square root because it's a plus sign. Anytime you have a minus sign, you have a square root. But see this plus sign right here? Do you see it? You have to kind of use your imagination. Do you see it? See that plus sign? There it is. It shows up again there. Okay? So arctangent has a plus. Arc sine starts with a 1, but it's a minus. Okay? And see this secant u? Do you see the secant u? It has a second u. Do you see the second u? There it is. It tells you it's going to have a second u. There it is right there, the second u. Okay? So that's how I memorize that. Okay? But it's actually not easy to memorize. Everything has a square root. This one has to be 1 first, 1 minus u squared. This one has to be u squared first, u squared minus 1. They're really different. The nice thing, though, is if you've memorized this one, you've memorized this one, because this is always just, the cosine's always just a negative. Okay? If you've memorized this one's just the negative of this. You guys see that? And if you've memorized this one's just the negative. So the nice thing, I guess, is there's really only 3 you have to memorize, and the other 3 are negatives. Okay? All right, so let's go ahead and apply this. And you guys will see that the application is not as terrible as the formulas, although you have to memorize the formulas. So don't worry, I made sure that it was terrible in some way. Okay, yes. Oh yeah, and then it has du dx, right? Does it have a du dx? Yeah, okay, so let me point that out. Remember, guys, that the numerators can bounce out, right? And u prime is really du dx, right? So this could bounce out and say 1 over the square root of 1 minus u squared times du dx. And of course, I could rewrite each of those for this thing to bounce out. Okay, yeah, thank you for pointing that out. I meant to point it out, but forgot. Okay, so let's go ahead and do some problems, and you'll see how this works. Is your first one arctangent 3x? Okay, so this is the derivative of arctangent. It's not the derivative of tangent, so you can't use secant squared. It's another formula. That formula is u prime over, it's an arctangent, so I see I have a plus sign. So that's just going to be 1 plus u squared. I just memorize this formula, okay? Whatever comes after the tangent, that's my u. So I circle it and I say u. I split this 2 ways, okay? The first way I find u prime. So the derivative of 3x is just 3, okay? The second thing I do is find u squared. 3x times 3x, hopefully you guys are comfortable with this, is 9x squared. Okay, so I figure out what u is. I figure out what u prime is. Maddie, can you put your phone away? I figure out what u squared is. Okay, once I find all of my components, I just plug it right into this formula. Look at this formula. U prime is on the top, so that's just 3 on the top. Then I just copy 1 plus, and then u squared is 9x squared. And bam! I'm done. Do you see how easy it is? Okay, yeah, but do you see the formula is really hard, but plugging in is really easy? Okay, you guys see that? Yes. Yes, so later on we'll simplify, but this you don't have to simplify any. The reason is because it's not a negative here. right? It's not negative, so you can't change this any. This is pretty much stuck. Okay, the other thing I need to tell you this. The most common wrong thing students do is instead of squaring the u, they square the u prime. Do you see that? So students will say u squared is equal to 9, but it's not. U squared is equal to this squared, and that's why I circle this and I go 2 ways with this. Okay, so just FYI, the reason I do this notation for you guys is so that you don't accidentally say u squared is 9. Everybody good with that? Okay, let's do another problem. Here you go. Arctangent x. How do you do this? You just write the formula. That's u prime over 1 plus u squared. Okay? I circle my u. My u is equal to x. I split this 2 different ways. Okay? One way is find what u prime is. What's the derivative of x? 1. What's u squared? So what's x squared? X squared. Okay, I figure out these 2 things, and then you plug into the formula. So u prime is 1. Then I just copy 1 plus. That's already in the formula. U squared. Oops, did I do this wrong? U squared is x squared. So this is x squared. Bam! The bam means I'm done, and it was easy. You guys got it? Okay, so let's do another one. Okay, here we go. Okay, this is a derivative of an arc sine problem. Write your formula, guys. Write your formula. U prime over. The hardest thing is knowing your formula. Okay, this is an arc sine. Remember this 1, this I here? That means I start with an I. It's actually underneath the square root. Okay, write your formula. That is the hardest part. Okay, this right here is my u. So my u is equal to, now be careful, I'm going to take the derivative of this. So I'm going to change it to x to the 1/2. Be okay with that. You don't have to. It's easier to take the derivative that way. All right, I'm going to split this off into 2 ways. The first way is figure out what the derivative is. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. We've done this before. That's really 1 over 2. Move this thing to the bottom. So that's x to the 1/2, which is really 1 over 2 square root of x. Okay, the things that are hard like this, you've already done before. Okay, all right. Then I split it off into 2 ways. Remember, one is u prime. The other is u squared. Okay, what's this squared going to be? What's the square root of x times the square root of x going to be? X. So that's pretty easy. All right. From here on out, I'm just plugging in. Okay, what is u prime? 1 over 2 square root of x. Do you guys see that? Everything else I just copy, but I plug into this u squared. So this is going to be the square root of 1 minus, what's u squared? X. Okay, that is my answer. Okay, I can simplify this because remember, what do numerators do? They bounce out. But guys, when they bounce out, if the whole thing bounces out, you still have a 1 on the top. Just make sure you understand. So what this is really equal to is 1 over the square root of 1 minus x times 1 over 2 square root of x. You guys see that? This is a great answer. Actually, if you left it like this, I'd be okay with it. But I think your test is multiple choice on this problem. So you need to be able to combine. And what I need to tell you is square root of 3 plus square root of 4 is stuck. Like you can't do anything with that. But square root of 3 times square root of 4 is actually square root of 12. Okay, yeah. Oh, you never flip the top fraction because what is the rhyme? Dividing fractions easy as pie, flip the second and multiply. So if you flip the second and multiply, this would be 1 over 2 square root of x times, this would be square root of 1 minus x over 1. So flip it. And you actually should get the exact same answer. Check that with this. Okay, so it should be the same. I'm bouncing out because I think it's easier, but if it confuses you, keep with your old ways of doing it. Okay, all right. So guys, when you multiply square roots, do you see that you can actually multiply x with 1 minus x? So if I simplify this, this is really under the square root, x times 1 minus x. If you simplify it, everything can actually go into the square root. Do you see how that works? And so the hardest thing here is going to be your algebra. Okay, trying to simplify and match up with the right multiple choice. Do you guys see how I did that? They can multiply together, right? Because 3 times 4, x times 1 minus x is x times a quantity, 1 minus x. Okay, let's try another one. Okay, this one's a little bit tricky, but you can see the hard part's not going to be putting it into the formula. The hard part is doing the derivatives that you already know how to do. Okay, so let's just write this formula first. The formula for the derivative of arcsecant is u prime over, okay, absolute value of u, because this is your second u, the square root of, whenever you have the secant, the u's sit next to each other. So it's u squared minus 1 instead of 1 minus u squared. Okay, Catherine, you're with us? All right, so then what you do is you find your u. Okay, so this is going to be my u, whatever is right after this thing. You split this up two ways. You split it up into u prime, and you split it up into u squared. Okay, I split it up like this on purpose because, again, when students don't split it up like this, when they just work down, a lot of times students take the square of the derivative, which is not what you need to do. Okay, u prime is this. Guys, what's the derivative of e to the u? Remember that rhyme? E to the u du dx, and that's it, that's a rhyme. Okay, it doesn't rhyme with anything. Okay, so so this is going to be e to the u, you copy it, but then du dx is just the derivative. This is your u, e to the u. What's the derivative of 2x? 2. So there, just multiply it. There is your u prime, e to the u du dx. It's just e to the u and then times whatever the derivative of the exponent is. Okay, what's u squared going to be? It's going to be e to the 2x squared. Guys, this is a power to a power. What do you do with the power to a power? Multiply. So this is e to the 4x. All right, and then now it's just a substitution. I'm going to substitute into this u prime. So u prime is on top. So e to the 2e to the 2x is on top. That's u prime. Absolute value of u. Well, I know what my u is. My u is e to the 2x. So I plug that in. The square root of u squared. Well, I figured out my u squared right here. It's e to the 4x. Did I do something wrong? It's just e to the 4x because it's 2 times 2x. It's not 2x raised to the 2. You just multiply these together, right? Okay, so that's e to the 4x minus 1. Okay, and that is my answer. If you thought about it for a long time, it might take a long time because it took me a long time. This right here is always positive, e to the 2x. The reason is because e to the x, when you graph it, or even if you graph e to the 2x, you're always going to be above the x-axis. And because of that, you can actually drop these absolute value signs because it's already positive. Okay, you can't always drop the absolute value signs, but if it's always positive, you can. And so because this is always positive, it turns out you can drop the absolute value signs, and these cancel out. Okay, so this is 2 over the square root of e to the 4x minus 1. On your test, I'm okay stopping here, just FYI. Okay, but I just want to let you know, this is always positive, so you could have canceled these out. Okay? All right, let's do another one. Actually, you do this one. You do this one. Write your formula, get your u prime and u squared, and plug in. Did anyone get the derivative of x over 3? 1 over 3, very nice. Okay, why? Because that x bounces out. Do you remember that? So this is really 1/3 x. The x bounces out. So the derivative of 1/3 x is 1/3. Did anybody get what u squared is? X squared over 9. Okay, now it's just a substitution. On the top, it's negative 1/3. On the bottom, you have the square root of 1 minus x squared over 9. Okay, I want you guys to, because this is a fraction, I want you guys to bounce that out. Okay, so if you bounce that out, what you get for your final answer is negative 1 over 3 square root of 1 minus x squared over 9. And I'm good stopping there, but you have to be able to bounce the numerators out. Are you guys good with that? Okay, Let's do another one. This one's kind of similar to your number 3 on your homework. Okay, what I want to do is take the derivative of y. Do you guys see, this is really like, I thought this was just one problem, but look at that. Oh boy, do you see it? It's really 2 derivatives, okay? And don't let the square root of 1 minus x squared confuse you. It's still 2 different derivatives, okay? So the derivative of arc sine x is equal to, isn't that u prime over the square root of 1 minus u squared, right? That's the derivative of arc sine x, right? The derivative of this right here, isn't this really, if I do a rewrite, isn't that really x times 1 minus x squared raised to the 1/2? How do I take the derivative of 2 x expressions multiplied together? Product rule. So this one's a product rule. So what I'll do here is I'll say plus the derivative of the first, which is 1, times the second, which is, that means you just copy the second. So 1 minus x squared raised to the 1/2, derivative of the first times the second, plus, this is product rule, plus the derivative of the second, okay? So this is chain rule, 1/2, leave the inside alone, take the power down by 1, take the power down by 1. So if you're at 1/2, now you're at negative 1/2. But don't forget, multiply by the derivative of the inside. Okay, derivative of the first, derivative of x is 1, times the second, plus derivative of the second, oops, what I forget, times the first, so times x. All right. Over here, remember the arc sine x, this is going to be my u right here. Okay, so I need to know what u prime is. So let me just, maybe I'll just do it right here. Okay, what is u prime equal to? 1. What's u squared equal to? X squared. Okay, so substitute it into this formula. That's going to be 1 over the square root of 1 minus u squared, but u squared is x squared. All right, I'm almost done. Plus this right here, do you see this right here is really just the square root of 1 minus x squared, right? Isn't that what this is right here? Okay, this right here is negative 2x times x. Isn't that really negative 2x squared right there? Okay, remember this is all over 1. Okay, so this is all over 1. So what I have is, and this is a plus sign, so let me put a plus sign, and I'm going to add negative 2x squared is on the top. On the bottom, I have 2 times 1 minus x squared raised to the negative 1/2. See if I, oh, no, not raised to negative 1/2. Raised to the 1/2, right? Because I moved it to the bottom. See if I did everything right algebraically. You guys good with that? Do you see what cancels out, actually? Yeah, the 2's cancel out. So if the 2's cancel out, let's see. 2's are going to cancel to 1. They don't disappear. They cancel out to 1. This actually is 1 over the square root of 1 minus x squared plus the square root of 1 minus x squared minus x squared over the square root of 1 minus x squared. You guys good with that? And actually, you could leave it like that. You're in good shape here. There's some other simplification you could do. You could get a common denominator of 1 minus x squared and get rid of this. But don't worry about it. That's really a good place to be right there. Okay, you guys good there? All right. And how about we do number 3 together, since a lot of people had trouble with that one. So go look at your homework, guys. Okay, look at your homework. Let's do this one together, and the other ones you should be okay. Here we go. You want y prime. So do you see that there's actually going to be 2 different problems here? Oh boy, do you see it? Okay, so right here, this is going to be what rule here to do the first one? Product rule. So let me just take this aside. Let me just do the product rule over here. And then I'm going to do over here 1 minus x squared to the 1/2. These are 2, these are 2 different problems I have to do. And then I'll just add the numbers, add the derivatives together. Okay, this is a product rule here. Here we go. It's going to be the derivative of the first. Okay, right? Derivative of x times the second. Now, what do I do when I say times the second? You just copy it. Times the second. okay, plus the derivative of the second. Okay, so what I need here is the derivative of arc sine, basically. Remember, and that is u prime over square root of 1 minus u squared. So I'm just going to take it to the side of my paper, figure out what the derivative of arc sine is. Okay, now split this up into u prime and u squared. U prime and u squared. Okay, this is my u right here. So what's the derivative of x? 1. What's x squared? X squared. Okay, then you just plug into this u prime over square root of 1 minus u squared. So u prime is 1. Square root 1 minus, I just copy the 1 minus. U squared, do I know what u squared is? X squared. Okay, so guys, this right here is the derivative of sine negative 1x. Okay, so what do I need to know? The derivative of the first times the second plus the derivative of the second. So the derivative of sine minus 1x squared is 1 over 1 minus x squared times the first. Okay, so I'm done with the left side. I might have some simplification, but I'm mostly done. Okay, let me add it with the derivative of this, whatever this is. And this is just chain rule, right? So you guys can do this. The derivative of this is going to be 1/2 times 1. Leave the inside alone. Leave him alone, guys. Take the power down by 1. Don't forget to multiply by the derivative of the inside. Okay? So what I get here is sine negative 1x times, do you see x over the square root of 1 minus x squared? Do you see that? 1 minus x squared plus what? Okay, we've done this problem before. This is over 1, this is over 1. Everything's multiplied together. So I get negative 2x over 2 times 1 minus x squared raised to the 1/2. You guys getting the same thing I get? But do you see your 2's cancel out? Okay. And look at your second term and your third term. Do you see they actually have the same common denominator? And what's x minus x? It's 0. They actually wipe out. Do you see that? Should I write it out a little bit better for you guys to see? Because you get sine negative 1x. Oh, this shouldn't be a times. I don't think this is a times, is it? I don't think it's a times. It's a plus. This should be a plus. See this red plus sign? This should be a plus sign right here. Yeah, the first time the second was 1 times the second there. Okay, so this is sine negative 1x plus x over the square root of 1 minus x squared minus x over the square root of 1 minus x squared. And so actually this answer is just nice. Look at that, guys. Started out ugly, turned out to be looking pretty good.